All right, welcome to the last section of Chapter 8, Section 8.8. We're going to look at complex numbers. All right, so complex numbers are numbers that are made up of real numbers, which we've been working with this whole time, and an imaginary number. So we're going to define a subscript I that's usually bold-faced as a number as the square root of -1. Now, you can't take the square root of -1 in the real number system, so we're going to be able to do this in the imaginary numbers. So then, if we decide to square both sides, I squared, squaring the square root cancels it out and gives me a -1. Now, if I start this out, I being equal to the square root of -1, I squared being equal to -1, I should never be written to a power because we're always going to be able to simplify it. So what I'm going to do is I'm going to create my imaginary I chart. So I to the first is I squared is -1. I to the third power, well, if we think about our product rule of exponents, when you multiply like bases, you add the exponents. So this is technically I to the first. So I squared times I to the first, 2 plus 1 is 3. Well, I squared is -1. I doesn't change, so I cubed is -I. If I make I to the fourth, okay, same exponent rule. I squared times I squared, 2 plus 2 is 4. Well, -1 times -1 is now a +1. So I to the fourth simplifies to 1. You can never have I to a power. If I have I to the fifth, of course, we'll build it based on whatever we have done so far. So I to the fourth times I to the first. I to the fourth is 1 times I is I to the sixth, we'll use I to the fourth and I squared. That's 1 times -1. That's a -1. I to the seventh will be I to the fourth times I to the third. 4 plus 3 is 7. So 1 times I to the I to the third power was -1. So that's -I. Not -1, -I. I apologize. Too many negatives here. I to the eighth is equal to I to the fourth times I to the fourth, which is 1 times 1 is equal to 1. Now there's a pattern here. If you notice and look at all the i's to an odd power, I to the first, I to the third, I to the fifth, I to the seventh, your answer is either a positive I or a negative I. One of those two. And then if you look at i's to all the even powers, it's either -1 or +1 for an answer. So one way that we're going to simplify I to a power is not to look at these in groups of 4, which some of the tutors in the math solution will tell you. Because if you had something like I to the 29th power, I've actually seen tutors tell you, well, you count 1, 2, 3, 4. After the fourth, it repeats 5, 6, 7, 8, 9, 10, 11, 12, and you count up all the way to 29, and then there's your answer. Huge waste of time. So we're going to look at this pattern and say, okay, if I'm starting out with I to an odd power, I know it's either a positive I or a negative I. We'll write that down, and then we'll determine the sign. And if it's I to an even power, we're going to say it's a positive or -1. We'll just figure out the sign. So technically, by knowing that if it's I to an odd or I to an even, we have half the answer. We just got to figure out the sign. Now, to determine the sign is going to be how many I squareds exist within the power. Now, we know I squared is a -1. And if you multiply an odd number of negatives together, you get a negative answer. And if you multiply an even number of negatives, you get a positive answer. So we're going to take I squared, which is your -1, And we're going to figure out how many I squareds are part of I to the nth. So for example, over here, I to the 8th, I could have I squared times I squared times I squared times I squared, 4 of them. And I say, okay, that's 4 negatives being multiplied together. That's a positive. So take the power n and divide it by the power 2. And if you get an even whole number, your answer is positive. If I get an odd whole number, then my answer is negative. So let's look at some crazy examples. I to the 75th power. Okay, because 75 is odd, I know my answer is I. I just have to figure out the sign. So right below this, you are going to write down 75 divided by 2, enter it in your calculator, and you get 37.5. Now, I only want to look at the whole number, so ignore the decimal part. 37 is odd, therefore my answer is negative, and you put a negative in front of the I. If I had I to the 89th power, again, 89 is odd, my answer is I. 89 divided by 2 is 44 point, we don't want the 0.5, we just want to look at the whole number. 44 is even, therefore my answer is a positive, so I'll put a positive sign in front of my I. That comes from the 44. If I had I to the 102 power, okay, 102, that's even. My answer is a 1. Is it positive or negative? Well, take the 102, divide it by 2, you get 51. That's my whole number. 51 is odd, and my answer is negative. If I had I to the 124th power, that's equal to 1. 124 divided by 2 is equal to 62. 62 is even, therefore my answer is positive. And that's how you simplify I to any power. I should never, ever be written to a power. It can always be simplified. All right, next we're going to simplify radicals with negatives in them. So we know that negative 1 gives us an I. So what we want to do is we want to factor this negative 1 out of every negative radical we encounter. So by definition, negative 3 is negative 1 times 3. And then we can separate this as the square root of negative 1 times the square root of 3. And square root of negative 1 is I times the square root of 3. So that's my final answer. Now, the one thing we don't want to do is sit here and write out all these steps. So we're going to shortcut this. Anytime you see a negative inside of a square root, you circle it, draw an arrow out to the front of it, and put an I. Once you do that, now you can deal with the square root of 4. Now that this is positive, I can say, wait a minute, I know the square root of 4, that's 2. So I times 2, 2I is my answer. Now you got to be careful with these next two because I don't want you to think negative parentheses negative and say, oh, look, 2 negatives makes this a positive. Absolutely not. You circle that negative inside the square root, you move it out to the front, and it becomes a negative I times the square root of 11. Now over here, we'll do the same thing. Take the negative out, make it negative I in the front because that I is going to be multiplied to that negative. And then we can start to break down 50 as 25 times 10. And the square root of 25 is 5. Now be careful. Big common mistake is to move the 5 to the front of the minus sign. No, it gets multiplied to the negative I. So this is negative 5I times the square root of 2. Next down here, be very, very careful. Do not multiply the 2 numbers on the inside. That's if they're real numbers. These are not real numbers. You have to take both negatives and move them out in front as an I. So now outside times outside, I times I. Now that the 5 and the 20 are positive, now you can multiply them together. So we're going to get an I squared times the square root of 100. Well, wait a minute, square root of 100 is 10. I squared is negative 1, so negative 1 times 10, negative 10. the square root of negative 16 plus the square root of negative 49. Whether I'm multiplying, adding, subtracting, you immediately take out the negatives. Now you can simplify the square roots. Well, the square root of 16 is 4, square root of 49 is 7. So I'm going to have 4i plus 7i. Well, I'm going to treat these like terms, as if it was 4x plus 7x would be 11x, 4i plus 7i would be 11i. All right, so what is technically my complex number? It's a real number, which we're going to call A, plus an imaginary, BI. Now, complex numbers are above the real number system, and right next to our real number system is this imaginary system. There's the real, there's the imaginary. But you have to be careful, because we saw in imaginary numbers, I squared is negative 1, I to the fourth was a positive 1. Some of these i's to even powers can move back into real numbers. Now, in the directions, you got to pay close attention. If the directions tell you to leave the answers in A plus or minus BI form, the answer will have to include a 0 if there is no real number or imaginary number. So let's say, for some examples, your final answer is 2. Your I terms canceled out. Well, your answer is not 2. Your answer is 2 plus 0i. The same thing if the real number portions combine together and cancel out. And negative 5 is what you have left over. No, you type in 0 minus 5i. If you type in the 2, you'll probably get a pop-up window that says, although your value is correct, it's not written in the right form, and they'll be prompting you to put it in that form. Now, we can add and subtract complex numbers. Complex numbers, as you notice, will always traditionally come inside parentheses like a binomial. 12 minus 3i, that's this complex number, plus 2 plus 7i. Well, we're just going to do nothing more than combine like terms. The 12 and the 2 come together. The negative 3i or minus 3i plus the 7i, bring them together. And 12 plus 2 is 14. Negative 3i plus 7i is a positive 4i. So this step right here is kind of like my thought process. Take this real number, add it to 2. Okay, 14. Take negative 3i and add it to positive 7i. Okay, 4i. Now, when you come to subtraction of complex numbers, you got to be very careful. This minus sign has to be distributed. So this becomes 6 minus 5i. Negative times a negative is going to be a positive 9i, which changes it to a plus. And the negative times the positive, or plus 8i, now becomes a minus 8i. And then we go ahead and combine like terms. Bring the 6 and the plus 9 together. The minus 5i with the minus 8i. 6 plus 9 is 15. Minus 5 minus 8. Keep the sign of the bigger number. Minus the signs are the same. Add them together. 5 and 8 is 13i. Multiplying complex numbers. Well, you can see a potential distributive property here. 2i times the 5, 2i times 3i. So this becomes 10i, and 2i times 3i becomes 6i squared. Wait a minute, you can't have I raised to a power. So that becomes negative 1, which makes this now plus 6 times negative 1, a negative 6, which has to go in front because the real number is first and the imaginary number is second. If I have a complex number times a complex number, you FOIL this out. 4 times 3, 4 times positive 2i. Negative 5i times 3, negative 5i times 2i. You'll get a 12, an 8i, a minus 15i, and a minus 10i squared. Oops, wait again, just like over here, I squared becomes negative 1, which will make my minus 10 into a plus 10. And then I can combine that with the 12. And as you see, my 8i minus 15i already combined that together to get minus 7i. So finally, the 12 plus 10 is a 22 minus 7i. If I multiply these two complex numbers together, notice one's a minus, one's a plus. You should recognize what's going to happen. As we go through the FOIL steps, 3 times 3 is 9. 3 times 2i is 6i. Negative 2i times 3 is minus 6i. And negative 2i times positive 2i is a negative 4i squared. Notice the two middle terms are opposites of each other, and they're going to cancel each other out. My I squared becomes a negative 1, and so negative 1 times 4 is going to be a positive 4 added together to be 13. So here's a case where we call those a conjugate pair. This will now become a complex conjugate pair. Okay, so now what I want to show you is you can take your calculator and you can grade all this stuff. All right, now your calculator has to be put in the A plus BI mode. So you have to hit the mode button, and you will see right down here, you will have real will be highlighted. You want to move your cursor to A plus BI and hit enter, so that becomes highlighted. Second mode, back to the home screen. So now here's the beauty of this. All these problems you can grade. For example, second square root of negative 4 is no longer an error message. It's the 2i. Now, speaking of I is above the decimal point. You can see that little scripted I on your calculator. So if I wanted to look at this problem here, the one that I added together, you type it in just as you see it to grade it. 12 minus 3 second I, close the parentheses, plus parentheses, 2 plus 7i. Boom, I just checked it. Now remember, you're going to have to show me your work for all this, but it's really nice over here. If you forgot to distribute your minus sign, your calculator will check the error. So if you put this down as plus 9 plus 8i and you have the wrong I term, your calculator will tell you. All right, your calculator will do the multiplications down here. You just type it in as you see it. So we had 4 minus 5i. And that was my next complex number, 3 plus 2i. It actually foils it all out together and gives you the 22 minus 7i, just like we had in our answer. So very wise to have your calculator checking everything out for you. All right, so that last problem we did right here was allowing us to cancel out all the i's from our answer. So complex conjugates always become a real number. So a shortcut for this is, if you probably recall when we were factoring, back in chapter 6, I believe, that we had a conjugate pair that would get us to a difference of perfect squares. But because you have the I being squared, which will turn the negative into a positive, okay? And so now my answer will be just simply a squared plus b squared. So 5 plus 3i times 5 minus 3i, it's a conjugate pair, just do 5 squared plus 3 squared, 25 plus 9 is 34. So this is going to come in handy when we divide complex numbers, because technically I is the square root of a negative 1, and we learned you're not allowed to have square roots in the denominator. So you are not allowed to have I in the denominator. No term can have an I. So multiplying the denominator by its complex conjugate cousin, 5 plus 2i, multiply top and bottom by 5 minus 2i, that will remove all the i's from your denominator. So you will FOIL the top, 2 times 5 is 10, 2 times negative 2i is minus 4i. 3i times 5 is plus 15i. 3i times negative 2i is minus 6i squared, which this will become plus 6 because the negative 1 times the minus 6 changes it to a positive. And on the bottom, 5 squared is 25 plus 2 squared is 4. You'll get a 29 on the bottom. The 10 plus the 6 is 16. And the negative 4i plus 15i is 11i. Now we want to separate this into two terms because it has to be in that a plus bi format. Now, if your denominator has just one I term, not two terms over here, but just a 5i, you only need to multiply I top and bottom. So distribute the I, 7i minus 4i squared, you get 5i squared on the bottom. Now remember, your I squareds become negative 1, so the minus 4 times negative 1 is a plus 4, and you'll have negative 5 on the bottom. So again, 4 comes first, 7i at the end, split it into two fractions, and you're officially done. Okay, now, using your calculator to grade these division problems. A lot of it depends on how new your calculator is. So if you have the TI-84 plus CE, we can type this in as alpha y equals, activate your fraction, top part we'll put in the 2 plus 3i, on the bottom 5 plus 2i. And if you get this long decimal, what we need to do at the end of this answer here is we want it to return it as a fraction. So you got to hit math, return your answer as a fraction, and then it gives us the answer that we came up down here. So again, you can check it. But if you don't, it's going to convert everything to a decimal, and that's because it has imaginary numbers in here. Now, if you don't have the alpha y equal to get to this fraction here, then you have to use the division symbol, and you will enter it in the following fashion. Parentheses 2 plus 3i, close the parentheses, divided by parentheses 5 plus 2i, and again, math, return my answer as a fraction, and you'll get this answer. Now, if you do have an older calculator that doesn't have this notation, it's probably going to look like this. 16 divided by 29 plus 11 divided by 29. And then you're going to see the decimal point, or excuse me, the I, second decimal point, right after the 29. Now this appears like I is in the denominator with 29, but it is not. Remember, the calculator knows orders of operation. So you have division and multiplication going on within this term. So this is 11 divided by 29, which is this fraction right here, then times I, which is technically putting the I up in the numerator or off to the side. So don't let that notation there fool you. That I is not in the denominator.